Welcome back. In the previous episode, we explored how to read METARs. In this episode, we're diving into TAFs, or Terminal Aerodrome Forecasts, which are vital for flight planning, approach decisions, and overall safety when flying into or out of an airport. A TAF provides a forecast of expected weather conditions at an airport for a specific time period, usually 24 to 30 hours. Unlike METARs, which give current observations, TAFs predict winds, cloud cover, precipitation, and visibility during the forecasted period. Let's take a look at the general format of a TAF. The report starts with the airport identifier, for example, EGLL for Heathrow. Following the identifier, you'll see the forecast time range in UTC. For example, 13/18/14/24 means the forecast is from 6 p.m. Universal Time coordinated on the 13th to 2400 hours UTC on the 14th. The rest of the TAF includes details such as wind direction and speed, cloud coverage, visibility, and any specific weather conditions expected. It may also contain information about temporary conditions, tempo, or probabilities of certain weather events. A TAF might look like this. Let's break it down. EGLL, Airport Identifier, London Heathrow. 131820Z, the time the TAF was issued, 13th, 1820 Universal Time coordinated. 28015G 25 kT, wind from 280 degrees at 15 knots, gusting to 25 knots. 10 sm, visibility is 10 statute miles. SCT 020, scattered clouds at 2000 feet. BKN 080, broken clouds at 8000 feet. 12M03, temperature 12 degrees Celsius, dew point -3 degrees Celsius. Q1009, altimeter setting 1009 HPA. TAFs are essential because they provide pilots with forecasted weather conditions that will affect takeoff, in-flight operations, and landing. Pilots rely on TAFs to help plan their approach, choosing the best route, altitude, and timing for landing. Let's now focus on wind data in TAFs. Wind is reported as direction in degrees true, followed by the speed in knots. If wind gusts are expected, the G abbreviation will be used. Wind gusts can affect aircraft performance, especially during takeoffs and landings, so it's important for pilots to review wind data in the TAF carefully. Let's talk about cloud cover. In TAFs, clouds are described in terms of coverage, few, scattered, broken, overcast, and altitude, in feet above ground level. For example, BKN 080 means broken clouds at 8000 feet. These descriptions help pilots assess visibility and determine whether they will need to rely on instrument flight rules, IFR, for approach and landing. Cloud cover in the TAF also indicates the potential for turbulence. Cumulonimbus clouds, CBS, are a clear sign of thunderstorm activity, which pilots must avoid. In cases where CBS are reported, pilots will adjust their approach, altitude, or course to avoid turbulence, lightning, or other hazards. Visibility is another crucial element in TAFs. If the forecast visibility is less than the required minimum for a visual approach, pilots will prepare for an instrument approach. Visibility is typically reported in statute miles or meters, and if visibility is expected to decrease, pilots will need to plan accordingly, especially in low-level approaches. Some TAFs also include temporary conditions, such as tempo or prob. Tempo refers to temporary weather changes expected within the forecast period. For example, if a TAF says, tempo 13/19/13/24 2 SMRA, it means there will be temporary rain with visibility reduced to 2 statute miles from 7 p.m. to 2400 hours UTC. The prob section of the TAF gives the probability of a specific weather event. For example, prob 3013/18/13/21 SMTS means there is a 30% chance of thunderstorms with visibility reduced to 1 statute mile between 6 p.m. and 8 p.m. Universal Time coordinated. Next, let's talk about TAF limitations. While TAFs provide valuable forecast data, they are not 100% accurate. Weather conditions can change rapidly, especially with fronts, tropical storms, or local weather patterns. Therefore, pilots should always check the latest meta reports, weather radar, and ATIS for the most up-to-date information during flight. A TAF is valid for a specific forecast period, usually 24 to 30 hours, but weather conditions can change beyond that period. If you're planning a long-haul flight, be sure to check for updated TAFs as the forecasted period progresses. Let's look at a real-world example of how TAFs are used. You're flying from New York to London, and the TAF for your destination airport shows high winds and cloudy skies. You may need to adjust your approach based on the forecast, possibly preparing for an ILS approach if visibility is poor or clouds are low. TAFs also help pilots decide if alternate airports are necessary. If the TAF predicts poor weather conditions at your destination, it's a good idea to check the TAFs for nearby airports to determine which one will be a better option. Let's also mention TAF updates. A TAF is valid for a specific time period, but pilots should check for amendments or updates as the flight progresses. Speci reports or amended TAFs may be issued if weather conditions change rapidly, and these updates provide more accurate weather forecasts. Now, let's talk about how TAFs work with METARs. While METARs give real-time weather observations, TAFs predict future conditions. Pilots use both METARs and TAFs together to get a full picture of weather conditions. A META can help confirm or update information from the TAF during flight. In the next episode, we'll continue with TAFs Part 2, exploring specific TAF cases and how to interpret forecast changes. We'll also look at spot wind charts and how they relate to TAFs in terms of flight planning and operational decision-making. See you in Meteorology number 54, Spot Wind Chart.